The Galileo case. Does it really prove that the Church was an enemy of science? What really happened in the Galileo incident? Let's look at it today on the Catholic Church, Builder of Civilization. Welcome to the Catholic Church, Builder of Civilization. I'm Thomas Woods. Today we're taking on the difficult question of Galileo, because for the past couple of episodes I've been trying to explain that modern scholars reject the old idea that the Catholic Church was nothing but an opponent of the sciences. In fact, you would be considered almost beyond help if you continued to argue that to a professional historian of science. Nobody takes that seriously anymore, believe it or not. They really don't. However, the Galileo case still occupies such a prominent place in the popular mind that it's, I think, perhaps the greatest obstacle in our paths to trying to persuade people that, in fact, the Church has not consistently been an opponent of the sciences or any such thing. So I think it's important to go into this Galileo case in a little more detail than we usually get. And I will say up front, as I said last time, that I'm not here to suggest that every course of action pursued by important churchmen, and even in this case a pope, was wise or prudent. In fact, I think it has damaged the Church's reputation tremendously. At the same time, though, in all fairness, I think it's only fair that both sides receive a fair hearing. And typically that's not what happens. What happens is Galileo is portrayed as the great hero who was irrationally put upon by ignoramuses from the Catholic Church. Well, it's time to at least hear both sides. Now, John Henry Cardinal Newman was the great 19th century convert from Anglicanism. Great many of you, I'm sure, have heard of Cardinal Newman. And he was a great historian in his own right. And he used to say that the Galileo case was, quote, the one stock argument against the Church with regard to the Church's relationship to science. Because he said, in effect, that this is the only argument people typically have. And that if you say to them, what if, for the sake of argument, I granted you the Galileo case? Do you have anything else? What else have you got? Again, most of the time, people will just kind of stand there, stare at you blankly, or run away, because that is all they have. So even if you were to grant the Galileo case, Cardinal Newman says this is the one stock argument that's always brought out. But people unjustly extrapolate from this one incident and then draw general conclusions about the Church and science. It's unjust. Well, what we're going to start with is a gentleman who lived before Galileo, who was a 16th century figure. Copernicus, Nicholas Copernicus, was a Polish astronomer. Copernicus believed, in general, in what we would call the Ptolemaic system, or system of the universe, or of our solar system. He had one change that he wanted to make, but let's first look at what did Ptolemy believe. Ptolemy was an ancient astronomer. He was a Greek, and Ptolemy proposed that the way the planets were arranged was as follows, that you had the Earth at the center, and you had the Sun and the other planets orbiting the Earth. And according to the Ptolemaic system, or sometimes called the Ptolemaic Aristotelian system, the planets orbited the Earth in perfect circles, and they orbited the Earth at a perfectly constant speed. It was also suggested in this model that the various heavenly bodies, including the other planets and the moon, were perfect spheres. Now, Copernicus took all this, just about all this, as we'll see, for granted. What he suggested, however, was that what we should do is switch a couple of these things. We should put the Sun at the center and have the Earth simply be one of the planets orbiting the Sun. But he kept everything else. He kept the perfect spheres. He kept the perfectly circular orbits and the constant speed. He kept all that. He simply said, let's put the Sun at the center. This became known as the so-called heliocentric system. The system that put the Earth at the center is known as the geocentric system. Now, this is not a ridiculous system, by the way, the pre-Copernican one. The idea that the Earth is at the center and everything's orbiting it, Let's just say, first of all, that that's not a ridiculous conclusion. It does seem to comport with common sense. We don't feel like we're moving, right? People standing on Earth, we don't feel like we're moving. And in fact, we speak of the sun rising and the sun setting. We speak in this way. So it's not a ridiculous position. And as I'll show later on in our episode today, there were actually some excellent scientific arguments in favor of the idea that, in fact, the Earth was motionless and it was the sun that was orbiting the Earth. So we'll put that to one side. And we'll also note that this system actually worked very well for observing planetary motion. It actually worked pretty well. It wouldn't have lasted for over 2,000 years or 1,500 years anyway if it didn't sort of work. It does sort of work. Now, the system that Ptolemy proposed wound up getting a little more complicated over the years in order to make his system correspond to what was being seen in the sky. So it is true, he had to add things called deferents and epicycles, but roughly this was his system. The Earth at the center, the planets going in constant speeds and circular orbits, and with perfect spheres. So this is the system that Copernicus is going to overturn slightly. Copernicus puts the sun at the center. Now, Copernicus died in 1543, and he, in fact, as he was practically on his deathbed, he got to see, he had just published his work at the urging, in fact, of cardinals. Catholic cardinals urged him to publish his work. And he dedicated his famous book to Pope Paul III when it was published in 1543. He was afraid primarily of ridicule not by theologians, but by astronomers who had very good arguments against the idea that the Earth was in motion. As I say, we'll get to those later. But the Copernican system shared much in common with Ptolemy. It just switched the Earth and the sun. But it was subject to no formal Catholic censure until the Galileo case in the next century. His system, his so-called heliocentric system, was taught as a legitimate theory at Jesuit universities throughout the 16th century. Nobody got in trouble for this, and so on and so forth. It was just fine. It was treated as a theory. Now, in the 17th century, early 17th century, Galileo comes along. Now, Galileo was responsible for discoveries in physics and other areas, but we're focusing on what he saw in his telescope. Because although he didn't invent the telescope, he put it to important use. Because when Galileo looked in that telescope, he was able to see things that undermined aspects of Ptolemy's system. For instance, Galileo noted that clearly there are craters in the moon. I mean, the moon is not a perfect sphere, so that spherical thing is wrong. He noted that there were moons orbiting Jupiter. This contradicts Ptolemy because here we have something orbiting something other than the Earth. These moons are orbiting Jupiter. But more than that, as Jupiter is moving in its orbit, its moons are staying with it. One of the arguments against the idea that the Earth could be moving was that if the Earth moved, it would leave the moon behind. But here's Jupiter moving, and its moons are orbiting with it. And he observed other things through his telescope as well. These things could not be reconciled with the model of Ptolemy, in which everything orbits the Earth, and so on and so forth. Now, Galileo and his work were in fact welcomed and celebrated by prominent churchmen. For instance, in late 1610, Father Christopher Clavius wrote to tell Galileo that his fellow Jesuit astronomers had confirmed the discoveries that Galileo had made through his telescope. Galileo was greeted with enthusiasm in Rome in 1611. There was a day of lectures given in his honor. He wrote, "I have been received and shown favor by many illustrious cardinals, prelates, and princes of this city." He enjoyed a long audience with Pope Paul V and enjoyed a day of activities in his honor at the Jesuits' Roman College. In 1612, for the first time in print, Galileo said that he favored the Copernican system, at least the part about the sun being in the center. He believed in the heliocentric system. Well, this did not get him in trouble. In fact, in this particular writing, one of the many enthusiastic letters of congratulation he got came from the future Pope Urban VIII, who in fact was the Pope who, as we'll see, later got Galileo in some trouble. But in 1612, there was no trouble at all with what Galileo said, and yet it's the same thing. So what's going on here? Well, again, the Church is arguing that the Copernican model is okay as a theoretical model, but it hasn't yet been proven to be the literal truth. He believed that the sun really was in the center. It wasn't just an elegant model. The sun really belonged in the center. That really was it. The earth really was moving. But as I say, he couldn't really prove this. The evidence that Galileo had that the earth was in motion consisted, for example, of arguing from the evidence from the tides. Of course, we know the waves at the ocean. He argued that the reason that we see waves at the ocean is that the earth is both rotating and it's revolving. So it rotates and it goes around the sun, and the result of all this is it's shaking up the water and creating the waves in the ocean. Well, if that sounds like a silly explanation, that's because it is. So people didn't necessarily buy that. But meanwhile, Galileo was walking around claiming that all biblical verses that make it sound as if the earth is motionless need to be reinterpreted. This was the problem. Can a layman just run around demanding the reinterpretation of biblical verses on the basis of a scientific theory that he can't even prove? And this was at a time, remember, when the Protestant Reformation was not exactly yet a distant memory. And Protestants were always hounding the Catholic Church for not giving the Bible its due and not listening to the Bible enough. So here's Galileo going around saying the Bible's got to be reinterpreted. So let's come back and try and make sense of what ended up happening to Galileo and who was right and who was wrong. Welcome back to the Catholic Church, Builder of Civilization. I'm Thomas Woods. We're talking about Galileo, and before the break we noted that Galileo believed very passionately in the Copernican model, by which he meant that the sun was at the center of our solar system, so to speak, and that the Earth was one of the planets that orbited it. But as I also suggest, that he did not have ironclad proof of that by any means. And if you talk to any historian of science who knows anything about the 17th century, he will tell you that the geocentrists, those who disagreed with Galileo and put the Earth at the center, still had a very good and reasonable scientific argument. And I want to amplify that point and just show that it wasn't a question of complete morons irrationally opposing Galileo, and Galileo being a wonderful genius who has to tolerate all these stupid ignoramuses. To the contrary, they had extremely good arguments that he could not answer. The main argument involved something called stellar parallax. Now that sounds very complicated, but you'll be amazed at how simple it is. Let's first just look at that word parallax. This is a phenomenon that we're all familiar with. We see it every day. Parallax shift works as follows. Let's suppose, for lack of a better prop, that this candle is my mother, and I'm on a merry-go-round as a child, and I'm looking at my mother watch me go around the merry-go-round. And let's suppose that over in the distance there's a tree over here. But let's say that over here there's a hot dog stand. So here I am, I'm going on the merry-go-round, and I'm looking at Mom, and I'm waving, and when I get to this part of the merry-go-round and I look at her, I see her against the tree. But when I get to this part, and I look at her from this angle, I see her against the merry-go-round. Well, I don't say to my mother, hey, how come you're shifting around while I'm on the merry-go-round? I just know that in each case, it's because I'm looking at her from a different angle. When I look at her from this angle, I see her against the tree. When I look at her from this angle, I see her against the hot dog stand. This is called a parallax shift. It's why, if you look at a close-up object against a background, and you look at it with one eye, and then you look at it with the other eye, it seems to shift against the background. It's not because the object is actually moving, it's that you're looking at that object from a slightly different angle when you look at it from either of your eyes. Now, stellar parallax simply means a parallax shift that involves stars. And here, I'm going to refer you now to this diagram. What we see here in the diagram, you'll see on the left-hand side there are two human eyes. A little disturbing, but just work with me here. Look at the top eye in the upper left-hand corner. When that eye is looking at the object in the middle is that yellow star. From that angle, it sees the yellow star against the blue background at the lower right of the diagram. Now let's look at the bottom eye. In the lower left corner, we see the bottom human eye. When it looks up at the object, it sees it against the red background. So the apparent shifting of that object is the parallax shift. Now let's look at our second diagram. This one is portraying outer space. And here, instead of two human eyes, we have two solid circles. The top solid circle is the Earth on, let's say, January 1st. The bottom one is 6 months later, when the Earth has gone halfway around the Sun. Now, what's going on here? Well, notice that, again, we have a closer-up object and some farther away objects. In the case of my merry-go-round example, my mother was the close-up object, and the tree and the hot dog stand were farther away. Here, we have a closer-up star, and then we have stars that are farther away. Now, on January 1st, when we look at that close-up star, we see it against the background of other stars more in the distance. Now, 6 months later, when we look back at that star, we're looking at it from another angle, so we're going to see it against a different background of stars. In other words, in the same way that my mother seems to shift, depending on where I am on the merry-go-round, close-up stars are going to seem to shift depending on where we are on the Earth's orbit around the Sun. So we should see a parallax shift. We should see the closer-up stars appearing to move against the background of the farther-away stars. Okay, that's the end of the diagram segment today. Well, what does this all boil down to? It boils down to this, that in fact, at that time in the 17th century, geocentrists were making that argument. They were saying, okay, Galileo, if you're so sure the Earth is going around the Sun, how come we don't see parallax shifts? Now, that's not a stupid argument, is it? Does that sound like a dumb guy argument? That's a very sophisticated argument, isn't it? But Galileo had no answer for that. And again, the Church's attitude was, if you can't prove to us that this is absolutely true, then the best we can do for you is say you can use it as a theory, but you certainly can't go around saying, well, the whole Bible needs to be revisited and reinterpreted. Can't do that till you prove it. And as I say, it had not been proven. The stellar parallax question had not been dealt with. And in fact, it wasn't until a very long time afterward that we got sensitive enough equipment to be able to detect the parallax shift. It is there, but the distances involved, with the stars being so far away from us, were so much greater than anyone thought. No one had any idea they'd be so far away. No one realized that the parallax shift would be so tiny because of the distances involved. It looked as if there were no parallax shift, and so therefore the Earth is motionless. So I think that's important, just as a matter of justice, to point out that these were not just stupid heads. That's a serious objection to Galileo. Now, Galileo refuses the compromise that's offered to him, whereby you can teach this as a theory, but at this point, it has not been proven. And again, the Church, as I said, is sensitive to Protestant charges that Catholics aren't paying proper regard to the Bible, so you have all these factors at work. Cardinal Robert Bellarmine said, look, if there were a real proof that the Sun is in the center of the universe, that the Earth is in the third heaven, and that the Sun does not go round the Earth, but the Earth round the Sun, then we should have to proceed with great circumspection in explaining passages of Scripture which appear to teach the contrary, and rather admit that we did not understand them than declare an opinion to be false which is proved to be true. But he said, as for myself, I shall not believe that there are such proofs until they are shown to me. Well, that's not a crazy position to hold, it seems to me. In 1624, Galileo was again received with great enthusiasm in Rome. The Pope told him that the Church had never declared Copernicanism to be a heresy and would never do so. And the Pope decided to hang on to this idea that Galileo could continue to teach what he wanted to teach as long as it was in the realm of theory, until such time, if ever, it should become established firmly as fact. Well, Galileo broke the rules. In 1632, he wrote his Dialogue on the Great World Systems. And in this work, he does not, in fact, stick to the idea that the Sun being at the center is a mere theory. He suggests that it's a fact. But worse than that was that Galileo wrote this dialogue as a dialogue. And one of the characters in this dialogue was a dunce, a dummy. And into the dummy's mouth, he put the Pope's opinions. well, you're not exactly going to ingratiate yourself into the Pope's favor by taking his view and putting it in the mouth of the idiot. But this was sort of typical of Galileo, who had a very, very, well, some might say, aggressive kind of way about him. He had a very irascible nature. He had a personality that left a bit to be desired sometimes. So, for instance, if you disagreed with Galileo on something like the nature of sunspots, he would come out and publicly call you a blockhead. And this was not a subtle person. And there's no subtlety at work when you take the Pope's opinion and you put it in the words of the fool in your dialogue. Well, Father Greenberger, who was a Jesuit, who was a big fan of Galileo, had said that if he had just kept to the idea that this is a theory and had not tried to make it stick as absolute fact before it could be proven, there would never have been an issue. But what seems to have happened here, the way I read it, is that you've got several factors coming together simultaneously to bring about this unfortunate outcome in the Galileo case. You have the fact that Galileo can't actually prove this, and that there is a very good argument against it, the parallax shift argument. He can't answer that. You have the fact that Protestants are putting pressure on Catholics, saying you've got to stick to the Bible, you can't just indiscriminately go and adopt novel interpretations unless you've got a really good reason. And then you have this clash of personalities between Galileo and the Pope. And that's a big problem as well. It's the way human nature is. Because as we've seen, this Pope, Urban VIII, had previously praised Galileo, had had no problem with Galileo publishing the Copernican theory, and even assured him that the Church would never condemn this theory. So it can't just be that the Church refuses to allow evidence or refuses to allow science. This was all allowed. The Galileo tragedy occurred because of the convergence of all these factors. Now, that doesn't excuse what happened. Galileo was, in 1633, told that he could not publish in this area at all. Does not excuse that. But on the other hand, it helps us to understand it a little bit better, and that's important too. Now, a good many scholars have begun to argue that people at the time, at least some of them, understood that the sentence against Galileo was intended in large part personally against him. Because, for example, Father Boscovich, whom we talked about last time, the father of atomic theory, openly used the idea of a moving earth in his work. And he never got in trouble, was never hauled before any church tribunal. So, as I say, a great many people have said that it was aimed personally at Galileo. Now, having said all this, as I say, my purpose here is not to say that there was no wrong done or that this episode is something to celebrate. But at the same time, I think we can understand that what actually happened here was the fruit not of any mythical Catholic hostility to science, but merely the unfortunate convergence of a variety of factors occurring at the same time. Because what we've seen in these past few episodes is that the Church's achievements when it comes to science are legion and are substantial. And that we have seen that more and more professionals who actually do this for a living, who study the history of science for a living, are saying that Galileo case or no Galileo case, the Church helped to make the scientific revolution possible. And it helped make it possible not simply because a great many Catholic priests engaged in important scientific discoveries, or wrote important scientific works, or composed great scientific encyclopedias, all of which the Jesuits did. It's not simply that. It's that the Church provided the framework in which science was possible. It made us believe that the universe could be understood by our minds and encouraged us to engage in this type of undertaking. And finally, even beyond that, the Church encouraged, yes, believe it or not, the free interchange of ideas. It encouraged a culture of debate and discussion. That was the culture that was fostered in the university system of the Middle Ages. And that's what we're going to look at next time. In the universities, we see the Western tradition of rigorous, rational debate, back and forth to discover the truth, taking root. And who was the great patron of that university system? The Catholic Church. So, I look forward once again to being with you and talking once again about another unfortunately unheralded aspect of our Western civilization, the Church's fostering of the university system, which gives us our great civilization. Thank you.